right. Hi, everyone. Thank you for joining our session, and we do hope that you're going to learn a few things today. In particular, we're going to be talking today about how to build Snowflake native connectors. My name is Pavel Niginsky. I'm a product manager with Snowflake working on data integrations. Today with me, Wojtek.
Hi, my name is Wojtek, and I'm a software engineer in the connectors team.
So we work together. We present together. So let's just get started. In terms of topics we're going to cover today, so there are going to be two buckets. So we will start with the theoretical part a bit. So we'll try to explain how we at Snowflake think about native connectivity and specifically how we think about building a native connector. And then the second part, from my perspective, the most exciting part, we will show this. So we have built a sample connector that we're going to show to you, and we'll double click on it and we'll show some of the code that we're using, how to do it. So the most exciting part, I think. So let me just get started with my theoretical part. So when we think about data integration, specifically ingestion in a traditional manner, we would think about three boxes here. So the first box is the source. The last box is the target, Snowflake in our case. And the box in between, an ETL solution, a tool that helps you move the bytes from A to B, from source to target. And there are a few characteristics related to this process. Some of those customers might find not super great. For example, with this setup, usually the data flows via third-party cloud or third-party tools, so data hops from one place to another. It causes sometimes some data delays, the pipelines can break, there might be some security questions. In addition to that, if it's a third-party, let's say outside of Snowflake tool, you would probably be thinking about license fees because it's yet another tool, so you would probably need to pay for that. And another thing is that if it's yet another tool, you would probably want to get this tool through some review, security reviews, so that the purchasing team would say, okay, let's get this tool in. And while some of those things are not super cool, you can ask yourself a question. Okay, if this setup is bad, if this what we're saying is a bad thing, and you know what? We don't think it's bad. While there are some things here that are not super cool, but it has been working for quite a long time, and it's been working with Snowflake. So we think that the question, if this bad or not, is probably not the right question to ask. The right question to ask that we think is, can we do better? Can we do better than that? And that's exactly the question that our customers are approaching us with. They're saying, hey, can we move from 3 boxes to 2? So can we have something where we just have the source and the target? So that's our customers are asking us, can we have something that we can just get the data from source to target directly? Can this thing be discoverable right within Snowflake so that I don't need to bother with buying something new, get those approvals, so that I know that the data is flowing directly, so that I know it's secure because it's within the Snowflake security boundaries, and that I don't need to care about extra license fees. This experience, our customers in our discussions, people are calling it native experience. It just comes up in the discussions like, hey guys, can you have something native? And even if this native part is built by you as Snowflake or by our partners or by someone else, our customers are telling us, we don't care. Whoever builds this, but we want this experience. And they were asking us, can we do this? And until recent, our answer to that was, it's pretty difficult. It was almost no. So the answer to this question. And the great thing about this particular summit that I and our team were particularly excited about is that right at that summit, we are releasing some of the pieces that are necessary to build the native connector we make it available to everyone. So this is the greatest part that we feel about this summit. We're going to be talking in a bit more detail what exactly this is, but the key message is that now Snowflake makes it available to everyone, all the components needed for that. So let me quickly go through some of the building blocks that we think are integral to build a native connector experience. I won't go in detail for every of this item here at the moment. Today, a bit later, we'll be getting to some of the items in a bit more detail, including showing you some code. But just to name a few, Snowflake Native Applications Framework. So it's in public preview now. It means that developers, engineers, application providers can just safely wrap their code, their intellectual property, so that no one's going to see it, nor customers, neither customers, nor Snowflake, not going to see the code. And they can distribute this code on the marketplace. Was not possible before. With Snowpark, it is generally available. You don't need to write your code in SQL, so you can now write your code in the programming language of your choice. So you can write it in Java, you can write it in Python, in Scala, it will work. Another thing I wanted to call out here is Streamlit UI. We didn't have this part before, we didn't have this building block before, so now an application will have a UI. We didn't have it. Some other things, direct external access, secret object, event table, snowpipe streaming, tasks, those components are available now. With direct external access, yes, it's in a private preview at the moment, but it will go public very soon. So those are components that are necessary to build a native experience, the experience that our customers are asking us for. But once we realized we have those building blocks, what's the next thing? So we asked ourselves, okay, let's start building, let's validate. Can we really use all those components to build a native connector? So we started building on our own. And while doing it, then we asked us another question. Can others do it? Can our partners do it? And this is the time when we went to our partners and we challenged them. Can you do this? Can you build native connectors using the primitives, the programmatic primitives that we're showing here? And you know what? They did. And I would really love to thank our partners, Informatica, S&P, Matillion, and Airbyte, for building their first native connectors on Snowflake. Airbyte built a LinkedIn Ads connector, Matillion built Google Sheets native connector, S&P built an SAP connectivity, and Informatica, SAP, and Oracle. So those four connectors will join some of the connectors that we developed on our own. For example, ServiceNow, it's been in public preview for a few months already. People love this experience because it's easy. Google Analytics raw data and Google Analytics aggregate data connectors that we announced at this summit gonna in private preview very soon, as well as database connectors, MySQL and Postgres, both in private preview coming out soon. And last but not least, Salesforce integration via sharing using Iceberg tables in private preview. So that was the customer and Snowflake perspective on how we think about this native connectivity and what components are there so that customers can get those connectors, not just from Snowflake, but also from our partners. But before showing you how we built a particular connector so that you would see how those parts are working together, let me talk a bit about how Snowflake thinks about data integration in general. So we think about three major integration patterns. First is data sharing. We love data sharing. Data sharing is great because you don't need to move any bytes. It's quick. And now, with Iceberg tables in private preview available, any source system that has Iceberg tables integration can simply share the data with us. But not every customer use case is the best fit for data sharing. That's what our customers are telling us. So for that cases, we're going to the second integration pattern, which is a pool-based integration. exactly this one, we will talk about much more today. So we'll show you a sample connector, we'll show you some code. The pool-based integration, this is the case when there is a data source which is exposing its data through a set of APIs, which are publicly available running on HTTP. So this is the time when you would build a connector, a native connector running on Snowflake. So this code will reach out to the external system, pull out the data through this API, and save it in Snowflake. That's the general approach. But it's not always the case when source systems provide the API. Maybe there's no API at all, or this API is hidden behind a firewall. What to do in this case? The third integration pattern, the push-based. In addition to a native application, there is a piece of code that we call the agent that will sit close to the source in the direct visibility, network visibility to the source, like think about database, MySQL, and binary logs. So this agent will extract the data from the binary logs of a database and will use Snowpep streaming to get the data into Snowflake directly. And a native application will orchestrate this process and will also make the ingestion process optimal in terms of cost performance perspective. We're not diving deep in all of the three, just for the interest of time. Again, the one in the middle, we're going to double click on it in just a few moments. We're going to give you an example. We have built specifically for this case a real connector to GitHub, to the real GitHub. So we want to connect to it, we want to pull some data out of it, we want to show how we did it. But so that you would understand a bit more on the conceptual level, the last theoretical slide, and then we're moving to the demo part. The pool-based connector, conceptually, a native connector, would have three boxes. Again, three boxes. So the extractor part that would connect to the data source using direct HTTP access. The middle part that would, depending on the case and the business logic that you as a developer would love to get into your ingestion mechanism, would do the mapping, loading of the data, some transformations if needed, that it got from the extractor part, and then it will insert and merge this data right into Snowflake. It's pretty simple, it's pretty straightforward, and that is, it's meant to be like that. And the last piece is the connector UI. So we think it's very important that there's a UI on top of a connector. So it's not just run through commands or through APIs, but just having a UI is an extremely important piece so that people are installing and configuring and running the connector, having the face on top of it. So once you have those three pieces, you will wrap them up as a native application, and you will publish it on the marketplace. And in case you don't want to monetize by some reason, or you just build a connector for your own organization, so you can just distribute this application by creating a private listing. So you don't need to publish on the marketplace. You can just say, here are the accounts that I want to use, so that people with those accounts will have access to this application only. So what we've done so far, so we talked about how we think at Snowflake about what a native experience is and what is a general approach to building a pool-based connector. But the whole idea of our meeting today is that we could really show you how to do it and how the connector looks like. So now I think, Wojtek, over to you.
Okay, let me switch. Okay. What you will see right now, we will show a demo of the connector to set the context, how it is working. And then after the demo, we'll walk through the code, how it is really built. And then we'll perform some small code changes and deploy the app to Snowflake to see it's really working. Okay, so let me start with the demo. So I have my Snowflake UI here. You can see the tab apps, and I have the example GitHub connector already installed in my account. So what you will just see is an app which connects to the GitHub API, fetches the data and saves it into Snowflake. Okay, it's okay, it came up. So for the interest of the demo, I've already put some values here into the inputs. So the first thing I need to do is to configure the connector. So some of the values are pre-filled already, like the destination database. So that's the name of the database where the data is going to be stored. The secret name is the name of the object which holds my GitHub API token. I've already created it. The integration name, that's the name of the object which handles the integration between Snowflake code and the remote endpoint, and the name of the warehouse where my ingestion jobs will run. So let me just hit configure, and under the hood there is a procedure which really does the configuration.
And we will show you in a few moments how this procedure looks like.
Yes, exactly. So, okay, you can see there is like a warning here. So it's on purpose. I've pre-filled the values. So that's something what we'll fix in the code, and it should disappear then. So right now the connector is ready to start ingestion. So let me put some sources here. So as we are talking about data, let's take Apache Kafka.
So we're going to GitHub now, searching for the organization, searching for a particular repository, connecting it for real.
Let's take Apache Beam.
While ingesting is running, just one point to mention. The UI part, this is just an illustration. By no means it's supposed to be a guidance of, okay, this is how a connector should look like. No, we'll be talking in a moment what exactly we're using, but this is just to illustrate the concepts from UI to the very ingestion.
So as you can see, I have enabled 3 sources for ingestion. Let's see the progress of it. I can even do an auto refresh, and you can see right now we are pulling the data out of GitHub. Let's see how the data looks like. So I can take the data. We can see like 500 rows are already there. Let's see how the data looks like. Okay. And we can see that that's a data of a GitHub issue. So right now, let's go to the code and see how we can build such a connector. So the thing you just seen is built using a couple of Snowflake frameworks and primitives. The main one is Native App Framework. So everything was wrapped up as a native app and deployed into Snowflake. The UI you've seen is built using the Streamlit framework. We've connected to GitHub API using the direct external access, which is a preview feature right now. The job which we scheduled is via the Snowflake task, which is generally available. All the processing and SQL execution is done via the Snowpark API, and everything is wrapped in a stored procedure which can be prepared in many different languages, but for the purpose of this demo, we'll stick with Python. So the flow will be like that will show you how the configuration part is done, and later how the ingestion is really implemented. But before we deep dive into the code, let's see the project structure itself. So on the right-hand side, you can see the project in the IDE. So it's just an ordinary Python project. But there are like a couple of specific files which are needed for the native app framework, like the manifest file, which holds some metadata and configuration for the framework, a setup script. So that's the script which is going to be executed when you will create the application instance. The purpose of the script is to create some database objects, grant privileges, and also create procedures, like the 3 procedures which we'll describe in a moment, for provisioning the connector, enabling the resources, and to ingest the data.
And one thing is that the setup SQL and manifest YAML, those are integral parts of the native applications framework. So we're not just diving deep now into this, but hopefully you had an opportunity a few times in these days. But those are not something that are like we invented. Yeah. This is really part of the native applications framework. We're just using it here.
So you can see also here is like a file with my Streamlit application. So that's where the code of the UI lives. And for the convenience of the demo, we've put all of the build artifacts into SF build directory. So the content of this directory is going to be transferred to a Snowflake stage, and out of it, we'll create an application package and then an instance of the application out of it. So let's now see how the UI part is implemented. So what you can just see right now, it's a piece of code of Streamlit. So the purpose of the UI was to take the input from user, convert it into the JSON, and later on, we are running a procedure with this input. Let's go deeper and see how the procedure really looks like. So the purpose of this procedure is to create the statements to either create the necessary objects or alter the objects which we've already created. So as you can see in line 11, we are creating the destination database. So that's where our data will land. Also, we are granting some privileges, and we are altering a procedure to associate it with a secret. So as you saw on the demo, I was placing the secret name into the input. So I need to associate the procedure to be able later to call the remote endpoint.
So basically, as a result of this, right, all the configuration, once we hit the config button, right, so we're going to have on the Snowflake side the necessary definition of all the objects needed to start the ingestion, right?
Yes, and on the end, we are saving the configuration to the database for a later use. So after this procedure is executed successfully, the connector is ready to ingest the data. So let's see now how the real ingestion is implemented. So the nature of ingestion is that it's a periodical task. So to be able to do it in Snowflake, to do something periodical or on schedule, there is a primitive called task. So the purpose of this procedure is actually to create the task and schedule it. So as you can see, we are creating a task which will run every 30 minutes. And when the time will come, it will execute a procedure which redoes the ingestion. We are giving a name for the task, but also the task needs to run somewhere. And as you remember from the demo, I was putting the name of the warehouse. So now I'm reading the name of the warehouse, and in the line 11, I'm sticking in the name of this warehouse for the definition for this task. And on the end, of course, I need to execute this query. So after this procedure executes, then the task is going to be scheduled and we can start the ingestion. So the last part is really the ingestion, how we will connect to the source and save the data. So up till now, there was no way to directly connect to a remote endpoint from the Snowflake procedure. But now we have the direct external access in preview, and it's possible. So we can see there is just a normal GET request to some remote URL. Of course, in many cases, the endpoint you are hitting is going to be secured. So that's the purpose of the secret object I had. Yeah. So thanks to the Snowflake Secrets API, I'm able to read the token and then stick it into my request. And now I have the data from GitHub. So the last part is actually to save it into Snowflake.
Let's talk a little bit about how we would be doing this connectivity if we didn't have direct external access. Just wanted to call it out because building a direct external access coming out in private preview now is a killer feature for us as a connector. Because before it was really difficult to do. Maybe we could just talk just briefly about how we were doing it before. It was a little painful.
Today we have a primitive called external functions. And you can go outside of Snowflake, but you need an extra cloud-specific infrastructure like API gateway. And you need to manage the gateway. And if you want to distribute the connector to your clients, they need to maintain the gateway. So it might be painful for them. Yes, so direct external access makes it much more easy.
Exactly, and this is when we were talking at the beginning about when customers were asking us, hey, can you build this native connectivity? Right? That's why one of the reasons why our answer was it was difficult. Because if you need to tell as a developer of a connector to your customer, hey, install a gateway on your end, it's a bit painful, right? But now with direct external access, there's no need for that. It's literally like from code line 1 to 5, right? It's basically just forming the request header, just running it with all the necessary things. So this is the beauty of it. Just wanted to share my excitement about it because we spent some time thinking about it.
Yes, so right now we have the data. Yes, after line 5, the data is fetched from GitHub, so now we need to save it. So thanks to Snowpark, we can create simply a data frame out of this data, and using the merge statement, save it into Snowflake. I'm using merge statement for a convenience because you can do update and insert in one shot. So if the data is already there in the database, I will update it. If not, I will insert a new row. So that's pretty much it. So let's now do the code changes and deploy the connector to Snowflake. Let me switch to the IDE. So that's the very same project you've seen on the slides, yeah? So we have the manifest file, we have the setup script, and we have the Streamlit application. So let's open the Streamlit application, and we can do some changes. Maybe I will change the title. Instead of example connector, let's name it Summit 2023 demo. Also, you remembered from the demo there was an warning that some values are pre-filled. So let me find those values.
It's just Streamlit doesn't like this pre-filling, right?
Here.
It's complaining about it a bit.
So let me delete this line. And the other one. Okay, done. So what we can change more is, instead of issues, maybe we can fetch commits. Okay, so we've done the changes. Now let me build it. I have a convenient script to run the build, but what's happening under the hood, I'm just using Python build mechanism. It's using hatch, and it will create me the Python package. So as a result, you can see the SF build directory. We have there the manifest, the setup script, the Python package, and the Streamlit app. So what I will do next, I will transfer it to Snowflake and create an application package out of it. I also have a script for it. So what is happening right now, I'm using the standard SnowSQL tool, and I'm transferring the files into Snowflake, into the stage, and then running a couple of queries to create the application package. So the last thing I need to do is actually install the application.
All those primitives are provided by Native Applications Framework. So this is the beauty of those things, right? So that you can run command line tool and then have an app.
So what is happening right now, I'm executing few scripts which will prepare me those secret objects, API integration, and also it will create me the instance of the application in my provider account. Let's wait a couple of seconds for the execution. Yes, we can see it's done. I will copy just the name of the secret because I need to place it then in the demo. So let's go back to Snowflake. You can see I've deleted the previous application, so I can see that there is an error. So now I should see a new one, and it is there. Yeah, just now I have deployed a new application. Let me try to run it. It will take a couple of seconds. So what you will see right now, that's the new application basically, yes? So the values are not pre-filled. I need to key them in. The secret I will copy from the script. Let me provide the name of the integration and the name of the warehouse. And let's hit configure. Hopefully it will run. Yes. So let's now try to fetch the data. I will just schedule one job, and we can explore if the data is really fetched. Okay.
Now instead of issues, we're ingesting commits from GitHub.
So let's wait for the task to start. It should start in a couple of seconds, and then we will check if the data is really different. Yes, okay, so the data is being fetched. Let me go now to the worksheet, and let's try to see the data. Okay, let me expand it. Let's see where is the URL of the resource. Yes, so it is commits. So we have changed it. We'll be able to connect to GitHub and download it. So thank you.
Awesome.